Okay, in this video, we are finding the resultant force of parallel forces by using graphical method. Okay, so here the parallel forces here. There are two types of the parallel forces here. One is the like forces, like parallel force. Here the number of forces are parallel. Their lines of actions are parallel. Lines of actions are parallel, but the directions are also in the same direction. They are called like. If the direction and the directions are same and the lines of actions are parallel to each other, they are called like forces, like parallel forces. One more type it will comes, that is unlike parallel forces. Parallel forces. It means your first parallel forces are there. It means their lines of actions are parallel to each other. But they are unlike. Unlike means their directions are different. Here, like this, the directions are different. So these are the two types of the parallel forces here. Okay. So today we will discuss how to find out the resultant of n number of parallel forces by using the graphical method. Okay. So consider a number of parallel forces. Say three like parallel forces. You have three parallel forces. They are like forces. It means their directions are in the same directions. P1, P2 and P3. You have P1 and P2, P3. Three parallel like forces are there. Whose resultant is required to be found out. We want to find out the resultant of these three parallel forces here as shown in figure. Okay. Now use the graphical method. I will go one by one step by step here how to find out. So this is called space diagram. This is called space diagram. Okay. Space diagram. First you need to use the scale according to scale and draw the position of the parallel forces here. Parallel forces. One more it will comes here, vector diagram. One more vector diagram. So the first step is use the Bose notation. You should use Bose notation for the given forces. How to give the notation according to Bose notation? As in the previous video I explained here. Just suppose P1 is there, force P1 is there, just mark in between P1, this is A and this is B. That is P1 lies between A, B. Similarly P2 lies between B and C. P3 lies between C and D. This is how the Bose notation. This will be helpful while drawing the other vector diagram here. Okay, that is the first step. Now come to the vector diagram. This is the vector diagram. Okay. Start with any convenient point, that is A. Okay. Now come with P1. First P1 force. Take with some scale, the proper scale, convert whatever the in terms of force is there, this Newton or kgf is there, convert this into in convenient scale, some millimeter or centimeter. Take some proper scale and start with A. Draw a line parallel to P1. That is, this is A and B. This is AB. This is the first force. You are converted this into the scale and you drawn exactly parallel to P1 force. Now start with B. Come to second force. Again this convert into scale. From point B, draw a line parallel to P2 with scale, with the converted scale. This is point C. There will be point C. Now start with C. come to the force P3, convert this P3 into some scale. From C, draw a line, scaled line parallel to P3 here. This is D point. Okay. So this is P1, this is force P1, and this is force P2, and this is force P3. Okay. Now select any point O here, anywhere. Select a convenient point O, join OA, OB, OC and OD. Okay, I am joining here OA, OB, OC and OD. Okay. Now come to the space diagram. After finishing this, come to the space diagram. Start with P1. Select anywhere on the lines of action of P1 a point P. You need to select anywhere on the line of action of the force P. Start with P. Draw a line parallel to OA. First start with here in this OA. Just this you need to transfer here in from P by starting with P. That is, I am just transferring this. That is, you need to draw a line parallel. This and this should be parallel. This I am marking that L here, this point. Here no matter, anywhere, but it should be, these two should be parallel. That is LP parallel to OA. Okay, you need to draw LP parallel to OA. Next, from P, this is OA. I'll write this one as OA. This one as OA. Now again start with P. What is the next line here? OB. Now start from P, draw a line parallel to OB. That is, draw a line parallel to OB. This is P, this is Q. That is PQ parallel to OB. Okay, next start with Q. The next line is OC. Start with C, Q, and draw a line QR. That is QR parallel to OC. You need to transfer. Okay, that is QR. This is R. From Q, draw a line parallel to QR parallel to OC. That is QR parallel to OC. Next, start with R. What is the remaining line left here? OD. Now start with R. Draw a line parallel to OD. I start with R here and I am just drawing a line parallel to OD. No matter here, anywhere you can, but it should be parallel. Here R, here I am joining as M. It means RM parallel to OD. Okay. Now here in the first force P1 you have P point. Just extend this point like this. Extend this point. And in the last force P3 is R. P3. Extend this line, same. And extend this. Where these two line meets, it is K point. Okay. Now take the scale. Start with K point. Take the scale. Draw a line parallel. draw a line parallel to OD. Parallel to OD. This is OD. Draw a line parallel to OD. OD. Okay. So this is the resultant vector. This is the resultant of all these three forces. Okay. Now you found out the position. It will be somewhere in the beginning. If you draw according to the dimension, you found out the location. You find out the location of the resultant. What is the magnitude of this resultant? The magnitude of this resultant is nothing but AD. It is full. This plus this plus this. Whatever you are adding here, whatever you are getting in the scale, convert that into Newton or kg in the force. That is nothing but magnitude of this R. So finally result, what I am getting here, magnitude of R is AD. That is AD. It is converted scale. It is converted scale to force. Okay, to force. Next, magnitude you found out, that is something. Now position of resultant, where it will be situated. Position of R is as shown in space diagram. As shown in space diagram. Space diagram. Okay. This is how you need to find out the resultant of all the parallel forces by using graphical method. Okay.